If I told you that in the beginning the universe looked exactly like it does today, would you believe me? The James Webb Telescope looked very deep into the early universe and found surprising galaxies that show exactly that the early universe looked like today's universe. This means that our science made a mistake when it calculated the Dark Ages. In this epoch, from the Big Bang to the formation of the first complex galaxies, there must not have been much except darkness, heat, and worrying particles. But now we see a universe that was already fully developed in this era. What does this mean for our science and astronomy? It could be that we are witnessing a revolution in physics and astronomy. A single image from the new James Webb Telescope has overturned all old beliefs. The image shows several galaxies that are so old that they should not actually exist, but they are real and our researchers now have to live with them. At the moment, the results of the Webb mission are being put through their paces. Scientists have to clarify whether we are really seeing galaxies here or whether the light sources could be something else. Then they have to check whether our previous measurement methods were correct. The next decisive factor is whether Webb was set up correctly or whether there was an error here. The telescope is flawless, that much we can already say. The age of the galaxies has also been confirmed. There is still the slight possibility that the measurements made using the redshift are incorrect, but experts doubt this. It is much more likely that our theories about the Big Bang were wrong. Researchers have found galaxies that existed 13.5 or 13.6 billion years ago. This would fall in the middle of the Dark Ages when there was supposedly no galaxies at all. Instead of baby star clusters, researchers are therefore seeing highly developed galaxies that must have been several billion years old at the time of the observation. The galaxies show such wonderful shapes and structures as we know them from today's galaxies. Some research teams have already held out the prospect that dozens, if not hundreds of other galaxies that were already highly developed will soon be confirmed. This would prove that the old galaxies were not just outliers from the norm but normal. James Webb also showed only a small section of the early universe on his deep image. If the galaxies are confirmed, we must continue to assume that there were as many galaxies in the universe 13.6 billion years ago as there are today. The data from the Webb telescope thus impressively show that the early universe does not look much different from our universe today. Can you imagine what is going on in the minds of researchers who believed in the Big Bang as an incontrovertible truth? Some are still hoping that the old theories are basically correct after all and that only our ideas about the development of stars were wrong. There are very few exceptional physical cases that would still make this possible, but the prospects of this are dwindling with every new Webb picture. If the Big Bang really happened an estimated 13.8 billion years ago, all we have to do is look deeper and deeper into space, and at some point, we must come across baby galaxies and protostars. But if the Webb telescope continues to show more and more evolved galaxies and stars in the future, astronomy will face a major challenge. Some astronomers have already presented evidence of galaxies with a redshift of 20Z. This would mean that these galaxies existed so close to the Big Bang that the proponents of the old ideas of the Big Bang and expansion no longer stand a chance. If all of Webb's new discoveries turn out to be correct, they raise fundamental questions about how the universe came into being and whether it really has a beginning. The second big problem for astronomy would then be the fact that somewhere in our physics there are serious errors, and this could affect our entire science. It could be that we have misunderstood light. It could be that our calculations are wrong because they always start from the universe as a closed space and cannot be based on infinity. Or it could be that the real error is a detail that we have completely overlooked so far. This very fact could mean that the crisis opens the door to completely new dimensions of space research and natural science. Imagine we have overlooked a force or the truth lies somewhere in the mysterious world of particles, and now we are forced to re-explore these areas because our old explanations are failing. It sounds crazy, but just a few hundred years ago, people thought the Earth was the center of the universe, and then they experienced a crisis and a whole new worldview opened up. The same thing is probably happening again now. We thought our universe had a beginning, but at the moment, the infinite universe is becoming more and more likely. This comes as a shock to many scientists, but others are delighted and look forward to new theories and new truths with open curiosity, while conservative scientists are still desperately searching for proof of the Big Bang. The new thinkers are already coming up with more and more new discoveries. A team led by U.S. researcher Joel Ledger at Penn State University has analyzed the light signals of the oldest galaxies on Webb's images in great detail. What emerged from this analysis makes the idea of a young universe seem ever more remote. The possibilities offered by the new telescope are fantastic. Imagine how Webb's instruments can break down ancient light into its constituent parts and capture individual waves that reveal exactly which elements dominated these unimaginably distant galaxies. The elements are a key to ancient cosmology. In the theory of the Big Bang and the Dark Ages, there must have been only light elements at the beginning of star formation. Only when the first protostars exploded did heavier elements enter the universe through supernovae, and only through these heavy elements was it possible to form galaxies as we know them today. The light elements in space are helium and hydrogen. These two are said to have dominated the young universe. Heavier elements such as carbon, oxygen, and nitrogen may only have been added later. But Webb shows that the galaxies close to the time of the Big Bang already contained heavy elements. This means that they definitely cannot be baby galaxies. Rather, the measurements suggest that these galaxies were already between 4 and 8 billion years old when they emitted the light that we analyze today. The birth of these galaxies would therefore extend far beyond the assumed Big Bang. Now we might think it's quite simple, that the Big Bang was earlier, but it's not that simple. The whole series of theories from the Big Bang to the Dark Ages to the assumed expansion of the universe is basically a chain of analogies. The theories interlock and build upon each other. Furthermore, these theories and explanatory models all conform neatly to the generally recognized laws of Einstein's theories of relativity. Einstein's mathematical explanations of the phenomena of the universe and the forces at work in it are the basics of cosmology. In short, you could say what doesn't fit into these calculations doesn't exist. But now the discoveries of the Webb telescope are pulling some cards out of the cosmological house of cards. We know what will happen then. The probability that the construct will collapse is very high. Many scientists are feeling the same way these days. As someone who has invested a lot of time and effort into building a house, then unfortunately they have to realize that the house was not as solid as they had assumed. The magical thing about natural science is that it can basically only be confirmed by real observations. As long as this real evidence is lacking, everything remains just a theory. It's clear that no one has ever seen the Big Bang. Researchers also thought for a long time that this was not even possible. After all, there was no light at the very beginning, and we can only observe the light that has traveled through the universe with our telescopes. Here and now, it's a stroke of luck anyway that we can look into the past, so to speak, the universe as it looked more than 13 billion years ago no longer exists today. Of course, only the light took so long to reach us that it shows us an imprint of the past. Today, this gives us the unique opportunity to look as far back as light sources have existed. James Webb can officially capture and display light that has traveled 13.5 billion years to reach us. However, the first deep images already show that the telescope can capture light that has traveled to us for 13.6 billion years, and possibly even 13.7 billion years. So, it will only be a matter of time before we can look back even further. Then perhaps we will see the truth. There is another small problem with the observations in physics. Many observations that are not entirely unambiguous are subject to interpretation. At the moment, we cannot yet see any sharp galaxies at such a great distance. We only see blurred patches of light that are only analyzed by computers. Our eyes and brains are unable to interpret what we see. Errors can creep in here with some of the newly discovered light sources. For example, it's not entirely clear whether they are the light of galaxies or the light of gigantic accretion disks around black holes. The astronomer Edwin Hubble, who observed the movement of very distant galaxies around 100 years ago, may have had a similar experience. Hubble came to the conclusion that these galaxies were moving away from each other and away from us. This led to the idea of expansion. In the 1980s, the theory was extended by the inflationary universe. This model postulates that the universe underwent an extremely rapid expansion phase immediately after the Big Bang. This inflation should have led to a universe that is remarkably uniform and homogeneous over large distances, which is also roughly consistent with observations of the cosmic microwave background. This basic radiation is regarded as an echo of the Big Bang and as a kind of basic information about all structures and movements in the universe. Ultimately, both theories also mean that the universe is by and large uniform. However, more and more phenomena are now emerging that prove that matter is not distributed as uniformly in space as expected. We may have further errors of interpretation here and another scientific house of cards about to collapse. Hubble could have made a mistake in his interpretation of what he saw and in his later calculations. This would mean that the basic reasoning behind the Big Bang and expansion was already wrong. Subscribe now to be part of every new video.